So I wanted to make a quick video about the trig functions just to try and help people. It was all a little bit last minute. So let's be clear about something. These functions are all what we call periodic functions, i.e. they just keep going on forever and ever and ever and ever and ever. Now you're always asked to find solutions in the range from 0 to 360 degrees, the full circle if you like. And so you're expected to remember that this is what the sine curve looks like, going up to 90, can back down symmetrically to 180, then down to 270, and then back up to 360. And so that is your sine x curve. Your cos x curve looks a bit similar, but just it's actually a little bit ahead, so it follows the same pattern, but it starts at 1, going down to 90, then further down 180, then back up to 270, and then up to 1 again at 360. And then your tan curve has these strange limits at 90 and 270, so it gets bigger and bigger and bigger and bigger, but it never gets to 90. And then at the other side of 90, it starts again down the bottom, comes up through the middle at 180 and up, getting closer to 270 but never getting there, and then repeats again there. So at this stage you just have to remember the three basic shapes. Okay, so if we look at a question like, can you solve sine x equals 0.5 in the range 0 to 360? So we've got our graph up here. What we need to do is recognize that that intersects with 0.5, because that's what I'm asking. When is it 0.5? At that point there, which is what we get from our calculator. If we do the inverse sine of 0.5, we'll get 30 degrees. So that's the coordinates of that point there. But because this graph is symmetrical, this distance 30 will be the same here. And so in order to get this other angle, I need to take 30 away from 180, because that's 180. So that 30 is the same. Right? So if one is there at 30, the other one will be 30 away from the middle there at 180. So that's how I end up with both 30 and 150 as my two solutions. Similar problem, solve sine x equals 0.7. So I put that in my calculator and I get 44.4, doing the inverse sine of 0.7. And that will give me this point here. So when x is 44.4, sine of x is 0.7. So that gap is 44.4. So the gap the other side will be the same length. So 180 take away 44.4 is 135.6. So that's where I've got my other solution. So it works in a very similar way with cos. Let's say you were asked to solve cos x equals 0.5. Well, if you put inverse cos of 0.5 in your calculator, you'll get 60. Because it's not the same curve. You remember it starts at 1, goes down to -1 and finishes back at 1 at the top. So solving this one gives us when x is 60, cos of x is 0.5. Right, that's that point there. Now it's not the same as the sine curve, but it has the same symmetrical properties. And so we can see that this 60 here has to be the same as this 60 at the other end. Right, so if I do 360 take away 60, I'll get the other solution. So that's why I've got 60 and 300. Similar, solve cos x equals 0.25. Well, if I do the inverse cos of 0.25, I get an answer of 75.5. So that's my first one there. That's the coordinates. And then if I subtract that from 360, I'll come back 75.5 from there because it's symmetrical. Then I'll get the other solution at 284.5. Now, tan, a little bit similar, but the shape is different, okay? So tan has this kind of repeating pattern like this, but with these limits here, these lines that will never get crossed. So if I have to solve tan of x equals 1, if I put that in my calculator, inverse tan of 1 is 45. So there's my first solution. When x is 45, tan of x is 1. Now this has a translational symmetry, so I can see that this will be exactly the same thing 180 degrees further along. So I simply add 45 to 180 to get the second solution. Similar again, solve tan x equals 1.3. If I put that in my calculator, I'll get 52.4. And so there's my first solution, 52.4. Tan of 52.4 is 1.3. So that gap there is 52.4. And so again, because of this translational symmetry, that will be the same, which means I'll just simply add 180 to it to get the second solution of 232.4. Now, questions in the exam usually look more like this. So you're asked to sketch the graph first. So if you sketched it, it would end up looking something like this. Okay, so you have to show that you recognize this recurring pattern and these limits that don't get crossed. So with tan, I find it quite helpful to put 90 and 270 in there just to help me get my shape right. But the question says, solve the equation 5 tan x equals 1. So you've got a bit of rearranging to do first. So the first thing I'll do is divide both sides by 5. And then I'll take the inverse tan of 1/5 to get 11.3. So if tan of x equals 1/5, then that's 0.2. So I'll put my line across at 0.2, and I can see there's going to be a solution there. That's right, that's the one that's 11.3. So my first solution is 11.3. And then because of the translational symmetry, the next solution there will be 11.3 bigger than 180, which gives me 191.3. Okay, so there it is in context. I had to do a little bit of rearranging. Now I'm going to show you one last example because there's just a little bit of trickery here which makes this one a little bit harder. So in this case we're asked to sketch the graph of y equals sine x. Okay, there it is. That's what it looks like. Starts at 0, goes up to 1 at 90 degrees, down to 0 again at 180, down to -1 at 270, and up to 0 again at 360. So I know that's what it looks like. But if I rearrange this function, first thing I do is take 4 away from both sides. Then I divide both sides by 5. I have that sine x is negative. Okay, and that means if I take the inverse sine, of -4/5, right, it's because it's down here, right? The line of -4/5 is down there. I get the answer of -53.1. So I'm getting a negative x value, which is a bit tricky, isn't it? Because it's outside of the range that I'm looking for. I'm asked to find the solutions between 0 and 360. But what's happening here is that that's my -4/5 or my -0.8. And that's the solution my calculator is giving me, which is a -53.1. Right? So what I have to do from there is recognize that this is my gap, the 53.1 that I use. But within the range 0 to 360, then that gap is there, that's 53.1. So my first solution is what I get when I add 53.1 to 180. And my second solution is what I get when I take 53.1 away from 360. All right, so that's just one last little bit of trickery that you just need to watch out for if you get a negative solution. Okay, so that's a quick overview of the trigonometry problems.